Good morning, class, and welcome to today's practical business lesson. Today we are discussing sizing tankless water heaters for the laundromat application. In recent years, boilers have fallen out of favor for laundromat use and been replaced by tankless water heaters because of cost, safety, and ease of use. Laundromats typically have a large water load, but only a portion of that is hot water, and an even smaller fraction is needed at a given instant. This understanding is crucial. Sizing a tankless system by merely adding up the maximum hot inlet flow of every washing machine would likely lead to a largely oversized system. Conversely, sizing it too low based on assumptions that most customers prefer cold water may result in slow fills and machine errors, frustrating customers. Hence, the correct approach is to size for realistic peak hot water demand while ensuring compliance with plumbing and fuel gas codes along with manufacturer requirements. Customer behavior in modern laundromats further complicates the calculation. Research reveals that fewer than 20% of customers opt for hot water cycles, especially when laundromat owners charge more for hot water cycles. The introduction of ozone sanitation systems has reduced hot water usage even more, as these systems efficiently work with ambient or cold water. Tankless sizing should thus be based on actual usage instead of fears about connected load. Two key variables dictate the sizing of a tankless water heater: flow rate in gallons per minute and temperature rise in degrees Fahrenheit. Here is the essential heat formula used. BTU per hour output equals gallons per minute, multiplied by 500, then by the necessary temperature rise. For example, if the incoming water temperature in winter is 50 Celsius and the required temperature for washing is 120 Celsius, the rise required is 70 Celsius. This means that each gallon per minute necessitates about 35,000 BTU per hour of heat output. Consequently, for a heater supplying 20 gallons per minute at a 70 Celsius rise, a staggering 700,000 BTU per hour output is required. Taking a practical example, let's look at a laundromat with 22 Wascomat WUD730 machines. Here, the total water use per cycle is approximately 597 gallons, and the combined connected hot fill flow reaches 257 gallons per minute. However, these figures can be misleading. The total water used includes cold fills and rinses, while the connected flow represents the theoretical maximum if all machines were using hot water simultaneously. Designing a tankless system for that maximum would lead to extreme oversizing, far exceeding actual demand. Instead, the key question should be, how much of that hot fill capacity is realistically in demand during peak times? It is preferable to employ the demand factor method to estimate hot flow during busy periods, emphasizing the necessity of a conservative fill coincidence factor, typically between 0.35 and 0.50. For an example without ozone, the calculation looks like this. If 20% of customers choose hot water and using a 50% fill coincidence, it translates to a need for 25.7 gallons per minute, requiring almost 900,000 BTU per hour. For a tankless unit rated at 199,000 BTU per hour, this implies approximately 5 units for a strong no storage design. Conversely, with ozone sanitation, where hot water usage may drop to 10% or less, the needed flow can significantly decrease, reducing the requirement to just 2 or 3 units. Moving on, we must note the potential pitfalls in sizing tankless heaters, highlighting common mistakes such as sizing from total washer gallons or ignoring customer behavior. Many laundromats mistakenly assume that all of their capacity will be utilized simultaneously, which skews their sizing calculations. It's also important to consider the winter inlet temperature because it can drastically impact performance. Sizing a tankless system necessitates thorough monitoring of customer preferences, as behaviors can shift and affect water usage patterns. Finally, there is peace in redundancy. An extra water heater ensures that the laundromat maintains operation during service events. The best system is a stage system with adequate gas supply, proper venting, and other code-compliant safety devices. In conclusion, for the example laundromat with its specific washer mix, a non-ozone store should generally plan around 4 to 5 commercial tankless units, while an ozone-equipped store could often justify 2 to 3 units. The right design creates a balanced system, ensuring the laundromat functions efficiently while adhering to all necessary regulations.